Hello 7, it's Mr. Stevens here. Today you're going to continue doing some work on prime and composite numbers, but we're going to look at something new called factor trees. So let me give you a quick bit of revision from the last class. We're going to try and find all the prime factors of 45. So what we want to do first is we want to list all the factors of 45. So an easy way to do this is to start with 1 and divide 45 by 1 and see what happens. And you get 45. So those are two factors. And then we take 45 and we divide it by 2. We don't get a whole number, so 2 is not a factor. And we divide 45 by 3, we get a whole number, it's 15. And then we keep going, we divide 45 by 4, we don't get a whole number. We divide 45 by 5, we get a whole number, that's 9. So 5 and 9 are two factors. Then we're going to keep going, divide it by 6, that's not a whole number. Divide it by 7, again not a whole number. And something you'll notice when you divide 45 by 7, the answer that you get is 6.4, which is lower than 7. This means that if you keep going up and dividing 45 by higher numbers, you're not going to find another unique common factor. Another unique factor, sorry. So now that we've listed all the factors of 45 here, all we need to do is identify which ones of these are prime numbers. And from this list, we know that we have 1, 3, and 5 that are prime numbers. Okay, now we have our second question here. Find all composite numbers between 60 and 80. So the easiest way to approach this question is actually going to be to identify the prime numbers, because there's going to be a lot less of those and everything else is going to be a composite number. So we know that all the even numbers are composite numbers, because all even numbers bigger than 2 cannot be primes. So we can write all those down. And we also know that numbers that end in 5 have to be composite numbers. So that only leaves us with a handful of numbers left that can potentially be prime numbers. Now we just have to decide, out of these 8 numbers, are any of them prime or do any of them need to go over here? So, let's think of any ways that we can make any of these numbers. I can think of a way that we can make 63. 63 is 7 times 9, so that means 63 is a composite number, and it needs to go in this list. I can also, oh sorry, I made a mistake here. That should say 69. I can also think of a way that we can make 77. That's 7 times 11, so 77 doesn't belong in our list of prime numbers. It should be over here as a composite number. There's one more, it might be a bit harder to spot. It's actually 69. We can make that by 3 times 23. So it doesn't belong here in our list of prime numbers. It is actually a composite number. These remaining 5 numbers in our circle are all prime numbers. So we have identified all the composite numbers over here on the left, and all the prime numbers between 60 and 80. Okay, so the stuff we're going to be working on today is called factor trees. And the goal of these factor trees is to reduce the numbers to only being a combination of all the prime numbers that make them up. Now, I'll show you what I mean by that on this first example. We have 24 here. We can break 24 up into 2 and 12. And what I mean by that is 2 times 12 equals 24. Okay, 2 we can't break up anymore, but 12 we can. We can break 12 up into 2 and 6. Remember what that means is that 2 times 6 equals 12. Now we've got another 2 here which can't go any further, but we can break 6 down into 2 and 3. Remembering that this means 2 times 3 equals 6. And now we can't break these numbers down anymore. These numbers at the end of our branches of our tree, these are our branches of our tree here that I've just highlighted in red. The numbers at the ends of our branches are all prime numbers. So what we've done is we've written down 27 as a product of 24, as a product of its primes, because if we get our calculator and we do 2 times 2 times 2 times 3, we'll find that that actually equals 24. I'll show you again what I mean over here with 60. Now we can break 60 up into 6 and 10. We've already done 6 before, so we know exactly how to do that. That breaks down into 2 and 3. And we can break 10 down into 2 and 5. And now the numbers at the bottom of our trees are all prime numbers. And what we can do now is we can go 2 times 2 times 3 times 5, and that actually equals 60. So you guys are going to do a bunch of questions now that are related to these factor trees. You'll find them in chapter 11 on Ion. You'll scroll down to page 528, and I want you to just start from question 1 and work down. Thanks, year 7.